Okay, so back to looking at choosing the microcontroller as we led up to this. Again, looking at the criteria, and we said that the three criteria: meeting the computing needs of the task at hand efficiently and cost effectively, the availability of software, hardware development tools such as compilers, assemblers, debuggers, and emulators, and finally, the wide availability and reliability sources or reliable sources of the microcontroller. And we said that you have to make some selections in terms of 8-bit, 16-bit, 32-bit, whichever is going to handle the task most efficiently. In doing a selection, you may find out that an 8-bit is all you need. You don't need anything that's has a higher capacity. And so the other considerations that we mentioned then: speed, packaging, power consumption, amount of RAM and ROM, number of I/O pins and timer, ease of upgrade, and cost per unit. And all of these are kind of a graded process as well. We're looking at doing trade-offs here. You have to look at each of these considerations and determine in some sort of priority which one fits your need the best. And speed may not be it. It may be cost per unit. So let's take a look at these factors. So in looking at this, the criteria for choosing a microcontroller, the first and foremost condition or criterion in choosing the controller is that it must meet the task at hand efficiently and effectively. Okay, so as we look at each of these, we have to keep these other criteria in mind. Okay, we need to look at how easy it is to develop the products around the microcontroller. Does the form, fit, function, factor work for the product that you're trying to develop in making the selection for the particular controller? So in each of these, you need to look at the availability of an assembler, and we're going to find out as we go through the course pretty shortly here what an assembler is all about, because we're going to be using the PIC-18 and we're going to be using assembly language in writing programs for the microcontroller. And for some of you, this may be a little hard to grasp, and others will get it right away. The philosophy here is helping each other to understand. So we're going to take a look at each of the commands as they're associated to the assembler. The availability of debuggers. After you write a set of code to do something that microcontroller is going to do in the product, do you have something out there that's going to test it? Is there something already available that matches the assembler to do the debugging and find out if there are problems in the code? The availability of a code-efficient C language compiler. In some cases, writing the code in C makes more sense. The assembler is very, very powerful, but the C language is a higher order language and doesn't require as much for the programmer to do down in the minutia. So we're going to see some of that because you're going to get an introduction to that. The availability of an emulator. The emulator, of course, is the device that acts like the controller and allows you to actually see what the end product is going to look like. Availability of technical support. The product provider, the folks that build the microcontroller, are they going to be there for you? Can you call them up? Can you send them an email? Will they come out and help you? I mean, there are lots of factors in dealing with technical support. The availability of in-house and external expertise. How many folks do you have on hand that understand writing the code and dealing with the hardware issues associated with your microcontroller or your potential microcontroller? How many folks in-house and how many folks can you call on outside? Do you have a contractor? Is there a sub? How are you going to handle that? And then third-party vendor support sometimes is better than the manufacturer. You may have somebody out there that will actually provide for you better than the manufacturer can. In a lot of cases, the manufacturer is not geared for providing support. They're geared for providing a product. The third party vendors are sometimes in a better position to provide the support that you may need once you make your selection. Wide availability and reliable sources for the microcontroller. Is it readily available? Can you get it in the needed quantities now and in the future? Sometimes you got to think in terms of, are you looking at a product that's coming to the end of its life cycle? You know, is the next big thing coming out? And because of that, will the quantities be limited? You may need to go back and look and say, okay, I'm going to wait for the next big one to come out and not buy the previous edition because I'm not going to have the quantities I'm looking for. Again, it's a trade-off. The 8051, which is another controller, was the leading 8-bit controller. The 8051 family had the largest number of diversified suppliers. So you need to look at other vendors and manufacturers that have dedicated massive resources to ensure wide and timely availability of their products. There's nothing worse than getting into the middle of a product that you're building and using a vendor or a supplier that's fixing to run out because they're not going to manufacture your product anymore. And then, are they stable, mature, and single sourced? Can they provide the quality that you're looking for in your product? The worst thing you need is to put a bunch of components in there like a microcontroller and find out that the software wasn't mature, or they don't stand up to heat, or whatever the factors might be. So there are lots of things that you need to look at when choosing a particular microcontroller for your product. Okay, so we're going to leave that here, and then we'll come back to mechatronics and microcontrollers and see how the two are really married together.